Alright, good morning guys. Checking if the stream is on. Looks like it's on. Alrighty. So I've updated the branch in case if you want to follow up. I did some coding yesterday in the evening because I had some free time and I thought why not work a little bit. So I've added from other projects, I've added Docker Compose and I've updated Grafana dashboards. I am still not sure if it's gonna work or not. I didn't test it. But let's see. We'll see, I guess. So the goal for today... Performance test. Okay, and delete this. Let's rename this. Is to see that we can collect metrics from Grafana Prometheus. Let's rename this to no. Not sure it's gonna work. Can't remember it by heart. Righty. So the overall goal is to play around more with metrics. Set up Grafana Prometheus, just basic setup. See that it works. Then I want to add another HTTP server here, so we can trigger. Actually, we need to add HTTP server straight away. Otherwise, how are we gonna trigger our metrics? Yep, let's move it up. Grafana Prof. Okay, and then we will add more test cases and we will look on, yeah. Okay, I guess this one was first, but it's already, well, not sure if it's working or not. I hope it's gonna work. Alright, as usually I'm gonna be doing 2 Pomodoro sessions. And Jitantai, yo my man. Alright, my timer got moved for some reason. Let me adjust it. I hope it's visible. Alright, so I'm gonna be doing one 90-minute Pomodoro session. Feel free to ask any questions, guys, but I might be checking them after the Pomodoro. Alright, let's jump into coding.
wide.
Hello everyone, Q Productions. Straight. Sorry, strange. Hello guys, if you're still here, Q Production, hey bro, I'm also thinking of starting streaming. Any tips? Yeah, I can give you some tips, although I'm not that experienced myself. Are you still here, Q Productions? I'm getting some kind of strange error with Docker. What is going on? What? Can't get the Docker. Can't download the image? Alright. Let's remove this. Okay, don't have time for that. Is my internet down or something? Nope. Why is Claude not answering? What is happening? Okay, this is interesting. Multi-stage build. Okay. Alright, so I'm getting fully quit and restart, reset virtual network adapter. Oh my god. Seriously? Yeah, we'll need to think about why I can't download the image from Docker. Okay, not gonna do it on the stream, obviously. Alright, let's add other test scenarios for now. Let's commit this stuff for now. Unfortunately, I cannot run Grafana Prometheus. I mean, can I? Okay, let's do for now. Let's skip it for now. Let's go in our partition state and let's prettify it. Okay. How should we do it? Probably we'll have different partition states. Right. Yeah, a lot of duplication will be, but it is what it is. Okay, let's rename this partition state lock. And this is going to be sync.Map. This is going to be all common. Alrighty. That. I'm gonna do this with a swap. Store key value, or just store. When do you store? Replace the value, okay. Check out the article. Load the store, swap. Okay, so we need to use swap. Yeah, so we have two maps. It's obviously going to be less performant, but we'll see how it's going to perform with reads. With writes, it's going to be slower because we have map internally, and we have a pointer, and we have a mutex as well. No way around it in Golang and overall, I guess. Yeah, so sync.Map has two versions of the map, so it's going to be... I'm curious how it's going to perform with heavy read, because it should perform faster. But if we are having two maps, I guess the second dirty map will be very small, and we're gonna have one map we are reading from constantly. Yeah, then we don't need to lock this map. The reads are being done without any lock at all. And we append into second map all the time, and then we swap them at certain point, right? Or how does it work? Yes, but so we have new values that's being promoted. So we are not storing the second like entire copy. We just store new values and then we add them to the read map. As I understand. Maybe some struck. Normal state. This when entry is valid. Point P points to the real value of the entity exists on those maps, meaning it's actively in use. Table read without any issues. Delete state. When the dead entity is deleted from it's not immediately removed from the read-only maps. Instead, the pointer p is simply set to nil. Okay. Signal that the entry has been deleted but still exists in the map. Expunged state. Where the key is fully removed. Okay. So we have soft delete and hard delete. Deleted, expunged. Okay, makes sense. So if we delete something from the map, we can still, there will be still a gap where we can read it. It still will be actually in a read copy, in a read version. The delete stage is between both read-only and dirty maps. Internally, there is a mechanism that eventually moves all deleted entries to expunge state. Retrieval both deleted and expunged entry can be retrieved in the same key as edit again. This means that the return of normal state are active once more. How it promotes dirty map. When you load get data from sync.Map, it always starts by checking the read-only map. Makes sense. If the key is found there, if we have something in the read map, great, you're done. Okay. But if the key isn't found, things get a little yeah, guess this is the interesting part. At this point, the system checks if the read-only map has been amended, meaning some data might be sitting in a dirty map. Now we are talking slow pass. sync.Map grabs Mutex and checks the dirty map to see if the key is there. Right, so we check read, then we go into dirty and we are locking it. So if we don't have something in a read, then we have to acquire lock and do essentially what I'm doing right now with regular map. Every time the system has to go through the dirty map, it counts that as a miss. Yeah, so essentially this is a cache. Keeps track of these misses with the map misses counter. If there are too many misses, it's a signal that the read-only map is failing behind and it's outdated, and too many lookups. At this point, the system decides to promote dirty map, meaning the dirty map becomes the new read-only map, and the old read-only map is replaced. Alright, so they're actually replacing each other. Meaning dirty map becomes the new read-only map, and the old read-only map is replaced. Okay. So we have the entire copy in the dirty map. Dirty map then gets reset to nil. Okay, so we are clearing it. Once we found the key, once the found key has been deleted, entity pointer set to nil, expunged. The load operation will ignore that entity and return the key doesn't exist, which makes sense as the key is not valid anymore. If you're frequently adding new key value pairs, the read-only map will eventually become outdated. When that happens, the system will have to keep falling back to the slow pass handle. Alright, yeah, so it makes sense why sync.Map is good for reads, because we are making reads without any lock. But if we are constantly adding, updating, first of all, this is eventually consistent model, right? So we're gonna be, something might be deleted already, got deleted, but it's still gonna be in the map, or we added something in the map, but we can't read it yet. Because we need to wait until, right, if there is too many misses, so once we have too many misses, then they swap. Alrighty. It can be recently deleted, expunged. This will be point to nil, set to nil, meaning the key has been released but still exists in both read-only and dirty maps. Expunge. This is when the key has been deleted for a while and is fully removed from the dirty map. Reviving the expunged key takes a bit more work compared to recently deleted one because it's no longer hanging around in the dirty map. In short, expunged keys are more gone. Okay, makes sense. They're removed from memory, right? These are still in memory, as from what I understood. There are two reasons for expunge state. First, when key is deleted, it is represented by a nil pointer, but the key itself still exists in both read and dirty maps. Okay. Over time, this soft deleted, yes, so essentially soft delete keys can pile up and bloat sync.Map with no way to reclaim the space they take up. Yes, that's where expunge state comes in. It serves as a middle phase that allows these entries to be cleaned up. Once the key is marked as expunged, it only exists in read-only map, and when the dirty map gets promoted to replace the read-only... alright, so expunge state... It's not... Okay, yeah, we are waiting for garbage collector, and then it's... So we have nothing that is referencing those values, and they will be cleaned up on the next GC, as I understand. Second, instead of removing those keys immediately from both maps, sync.Map takes a more lazy strategy, allowing them to be cleaned up in batches later on instead of one by one. Okay, but when does key go from a nil state to expunge state? Okay, I will need to read it a bit later. Probably it's a bit boring for you guys, but nevertheless. So essentially we need to swap. We need to swap old value I haven't used sync.Map myself yet. What is happening? Where is my... Okay, I've added... Okay. Find latest commit. Alright, how we gonna do this stuff? So we don't need to have any logs anymore, and we don't have them. Load. So now we are not deleting, we are saying that yes, state delete offset like so. Is there size? Range. Do we need to range through it? Oh wow, like this, right? It doesn't have built-in length method because maintaining an accurate, efficient count of the high concurrency map is technically difficult. Okay. Only this know if the map is empty, no exact count. Yeah, because we have 2 copies. Yeah, I guess we have to map it, to range through it. Okay, Key value. What is the key value? Okay, this is our key values. Okay, once again, how do we check it? Function interface. So we're just returning true. Okay. So we create anonymous function, which must take 2 arguments, but we don't care about arguments. So it's gonna be empty, empty. It's gonna be interface. All right. Actually, nope, doesn't work like that. State will be val into message state, return state. Okay. All right, where else we have errors? No more errors. Good. No error here because new partition state lock. Here we will add switch case. We will be switching over scenario. We have case of scenario. What did I name them? And we have lock. We are doing this stuff. If we have sync.Map, we are doing sync.Map. We'll add one more for channels. Partition state lock as well lock. Okay, let's actually test out let's make global config so we can the same for all. We will edit it in one place, but later on we will maybe revert that back. All right. Adota, hello, how's it going? All good? All good. Some weird reason I cannot download Go images, something wrong with my PC, but nevertheless, we can do some other stuff. Alrighty. Yeah, I can no logo image getting error, but something wrong with my PC. I need to adjust how it's where it's searching images. It's DNS resolution basically on my PC is something was up with it, but I was actually doing some stuff with it. That's why I think I kind of broke it, because I have Windows and I'm running Linux on Windows. So I mean, there are some. Nevertheless, I will fix it off stream. But for now, anyways, I want to add scenarios where we are testing, we are running just map and log. We have sync.Map. Okay, let's run our application with sync.Map and see that it's actually working or not. Okay, let's make commit duration 2 seconds, here 500 seconds, and here like a second. Make run. Start our application. Actually, let's move debugger here. Let's run it in debug mode. And yeah, we'll just curl it. Valid character, yeah, makes sense. And we want to send not log, we want to send sync.Map. Edit first body, invalid character. Where? Okay, we don't have any invalid characters. I think it's good actually, but we just need to set this to true so we can see logs. Okay. Looks good. Okay, let's stop it. And I have a simple question. Why not use Gobench for this? I know. Haven't tried it yet. I wanna, go from ground up. Start with very fundamental stuff and then add more. Like, I don't wanna use some tool which will do everything for me. I mean, it's nice, but do I learn anything? Will I get any knowledge? Maybe yes. I don't know. I haven't tried it. For now, just playing around with basic stuff, right? So just to explain Gobench is with marking thing in Golang chunks like testing, but makes sense. Yeah, I will check it out. Yeah, it's in my list. But for now, I want to do just running tests, right? See how many allocations I'm getting, yada yada. Then add Grafana parameters. I don't know, Gobench. Okay, maybe I will definitely look it up. But for me, the main concern is I need to test something in a real environment, right? And real environment, what I mean by that is something that is running in a container. Can I use Gobench in this case? maybe, I don't know. I can definitely use Grafana Prometheus, right? Because this is something that will be running in production all the time, right? Or similar tool. So I can log in at any moment and see what's happening with my container. That's why I'm adding Grafana Prometheus, stuff like that. In that case, Grafana is better. Yeah, that's what I was, yeah. But I wanna anyway look at the memory profile with pprof, right? And I don't know, maybe in this case, GoBench is better. Because I want to see what's actually happening, right? Which kind of functions are being run. I don't know if this particular example, right, is going to be very useful, but for now I just want to do very simple stuff, right? Just a map, we update it and see the difference. And I think pprof can help me with that. And after that, yeah, write an actual application, see which functions are consuming the most memory and if we can optimize them. But anyways, my curiosity started when, like in Go, it's written, right? Communicate not by... Just I forgot already. Basically use channels, right? For sharing memory. And I started writing code like I was writing everything with channels. I wasn't using any locks. And then I realized that locks, like a regular map with lock, if you have simple state, right, it's going to be more efficient than adding a ton of channels to synchronize data. So I wanted to see how much of a difference it's going to be. And also, yeah, play around with sync.Map to understand what are the benefits and drawbacks of this tool. Alright, I want to see if sync.Map actually working correctly. So we had initial state. But overall the goal, yes, to add Grafana Prometheus, because that's like pprof and probably like GoBench testing is just for learning purposes, and for reality, I guess, Grafana Prometheus or something similar. Okay, so we removed 5, 6. Okay, looks everything good to me. It should have been complex, and it doesn't look like it. Okay, let's add into makefile our tests. Where are they? And let's check them out. Here's my makefile. Which function do I have here? Right. Lock. Sync.Map. It's gonna show me. Yeah, let's make it. Okay, I think I'm blocking something. Not sure if it's working. Let's make it like 2 seconds. Or yeah, we'll place this in a routine. Actually, no. We'll place cancel. We need to wait here. Let's not wait. Okay. Mutex lock, sync Mutex lock. I have deadlock. Looks like it, but how come? Okay, yeah, durations I've set are probably way too small. Let's make this like a second. 15. Not even 2 seconds, maybe. Okay, a second. And here we'll give it like a 5-second duration. Here we can actually make this probably smaller to 50 and 100. Because it was way too small. Right. Yeah, I'm not locking anything. We're just exiting. Should I add workers? I will place. Then we will block the loop. Okay, let's just create over complicating this stuff. Okay, still I'm not locking anything. Why? Okay, I need to think about it a little bit. Basically, we need to sleep for 5 seconds, then close exit channel. Here we are blocked on exit channel. We are not doing anything in our... Let's wait here as well. Okay, now we are blocked. Okay, let's remove logging. I can see that we are logging. Pause. See how many allocations will happen. Okay, I'm logging still something. Fatal performance. What are we getting? Fataled about 39. Close of close channel. Oh yeah, okay, makes sense. I don't know. Let's make it stupid and simple. Just one of them. The first one will send a signal. Why am I logging this stuff? Just comment you out. Alright, so we get this many allocations. Let's see what's gonna be with sync.Map. And yeah, and adjust the sync.Map's code. Alright. Alright, so we got pretty much the same, exactly the same amount of allocations, but bytes per operations is way higher and way more allocations, which makes sense because we are creating way more structures, almost triple. Alright, because, right, let me take a look one more time at sync.Map. What do we have in you? Hash tree map. Yeah, we have all this stuff inside. Essentially mutex, atomic, root. What's in direct? Direct is okay, I don't need to look. Right, hash function, equal function, right? So we are allocating all of this stuff. Makes sense. That is slower, but obviously I was testing. Yeah, we will need to see how much memory does it consume. But in terms of operations per second, map so far is faster, which is expected. And we're getting way more allocations for sync.Map. Alrighty guys, I'm gonna be wrapping it up for today. I will need to understand why my PC doesn't allow me to download images. Push the code. If you are curious, it's in a branch performance offset loop. Right, this one. And Git repo is attached in the description. Okay, in the next videos, we're gonna add the same state management of the map via channels, and yeah, and we need to add Grafana Prometheus, and nicely suggested by Pomodoros that I need to look into GoBench and just, yeah, learn all those nice tools from Golang, understand how to use them, when to use them. I'm actually using GoBench. Oh, okay, I thought it's something different. You mean... Ah, testing.B. Okay, it's the same thing. Okay. Well, less tools to learn then. We killed, like the phrase, with one shot 2 rabbits. Okay. I'm curious if I can see something a bit more here, not just how many operations, how many bytes per operations and allocations. Maybe it can give more data. Probably I can limit the number of cores, right? Because I'm creating a ton of Go routines. Yeah, I'm sure I can configure it because I have 8 core processor. What if it will be 1 core? But that's for future thinking. Gomax prox, yeah, Gomax prox. Yeah. So I don't specify it as a test param. Yeah, I just set up as an env variable. Okay, makes sense. Alrighty, guys. I'm gonna be wrapping it up for today. Thanks everyone for watching again. See you next time.